Okay, this particular lesson is in Module 10, linear regressions. So we have spent a lot of time looking at linear equations and going through those, looking at the main easiest form of y equals mx plus b. And this particular lesson just kind of ties with it. So I'm going to kind of walk you through what your homework would look like and introduce some of the vocabulary necessary with it. So one of the things that we see here is this thing called correlation, okay? There is something that's referred to as a correlation coefficient. Correlation coefficients typically are represented with the letter R, and we want R either close to 1 or negative 1. Now, why 1 or negative 1? We want it close to 1 if it is a positive correlation. In other words, our values are going up. We want it close to negative 1 if it is a negative correlation, so our values are going down. So in terms of a linear, we're talking about really the slope, positive or negative. So that's what correlation means. So for this particular problem, it says determine what type of correlation. If you look at this scatter plot, these lines are in a pretty good line here. They're not exact, but they are going up and could form a relatively good line in here connecting a lot of those points. So this would be considered a strong positive correlation, not a perfect. If it were perfect, it would be just a straight line, but it's a strong positive correlation. Okay, what about this particular scatter plot? Well, this scatter plot is a little different because they are all over the place. So since they're not just going up, they're all over the place, this is what we would refer to as no correlation. They're not going up, they're not going down. So that would be considered a no correlation problem. Okay, which of the following regressions represents the strongest linear relationship between x and y? So again, here what we're looking for is our R value, or our correlation coefficient, okay? So we're looking at all of these, and we want to see which one is closest to 1 or negative 1. So really what we're doing is we're looking at the decimal values. So this one is about 0.3 away from 1. That one's about 0.5 away from negative 1. This one's only 0.1 away from negative 1. And again, we're a little bit less than 0.3 away from 1. So the one that has the strongest correlation would be this one, because that value is closest to negative 1. So when you're looking at this, it's about the value being close there. You're always looking at this correlation coefficient R. And you can actually find that on your calculator. And we'll do some of that on the calculator. We're going to actually utilize the Delta Math calculator to do it, but the way it's represented is exactly the same on your graphing calculator. So if we take a look at some of these values here, like A, what is A? A is basically M. Remember in the previous slide I said y equals mx plus b. So here M, calculator chooses to use the letter A, but they're the same thing. So what do we always say about math? Same thing in different ways. It's a different way of representing your slope. So what this does is when we do a regression, we're actually using data points in order to create a fit, a line of best fit, a line that gets as close to the points as possible. The reason we use a calculator to do this is because it gives us the most precise line equation. If we did it by hand and just picked two particular points, all of us could pick different points and get different equations. So using the calculator takes into account all of the points collectively and gives us the best fit line. So if we were to take it, and this is our best R value, then we would take regression 3, and the equation of our line, if we take these values here, the equation of our line would actually be y equals negative 20x minus 14.8. And if I graph that line, it would be the line that was closest to as many points as possible. Things that we know, the line is going down because the slope is negative and because our correlation coefficient was also negative. Also, my y-intercept is a negative. Now again, this is a line of best fit. What does that mean? These values are not exact to the points because again, it's a scatter plot. It's not necessarily a perfect fit. How would I know if a line is a perfect fit? Then again, my R value would be exactly -1 or 1. If that happens, that is a perfect correlation. That means all my points are in a line. It is a linear equation, or again, an arithmetic sequence if you go back and refer to when we were talking about it in sequences. Okay, so here's a particular problem where we are actually going to take data points and we're going to use it again not on our graphing calculator, but I will show you in class how to do that, but instead do it on the calculator with Delta Math. So the first thing we're going to do is here are our data points. Okay, so this is like my x, this is my y. One thing to note, how it's represented. Okay, that's always important because on a calculator you wouldn't want to do these in thousands, so you put them in values that make more sense. So the first thing you're going to do is you're going to copy these values and then you're going to open your statistics calculator. Once you open your statistics calculator, this is what you're going to see, and you're going to see this menu up here, Edit Lists. So you're going to do that right after you paste the values. So you've copied those values, you want to paste them. So that's going to put X is here, Y is here. They call it L1, L2. The same as will be true in your graphing calculator. So here the values are pasted, sorry. Next we're going to click this menu, Edit List, and we're going to choose from that a calculate. Now what is it we want to calculate? And again, this fits a lot of stuff that's on your graphing calculator. There are different types of regressions. What we want to do is we want to do this linear regression. Now pay attention to this on your graphing calculator though, because there are two of these. We want the one that says AX plus B, okay, much like MX plus B. So we're going to select that one. We do want to turn our diagnostic on. Now this is something you would also have to do in your graphing calculator, and this is under the settings. Okay, so again, we'll go through all that, and I'll show you how to do that on the graphing calculator. So it calculates it, we push calculate, and here are our values. Now we ignore R squared. We also get this on our graphing calculator. So we look at our value. First of all, this is positive. So what's that tell me? My scatter plot has a positive correlation. That means my points are going up. It's pretty close to 1. So that means this is a pretty good fit. It's a pretty strong positive correlation. Here again is my slope, and this is my y-intercept, and that would give me a representative line of those points for the equation. Now what you'll see when we do this on your actual graphing calculator is we'll take those values, we'll do our scatter plot, okay, whatever it looks like, and then we'll actually graph this particular line to represent it, and it'll graph the line, and it kind of shows you how well it fits to those points. So again, right now we're just trying to get some of the basics, some of the vocabulary with this, but also we'll do some practice with this, showing you how you can do it on your calculator. Now one of the things with the calculator though, things you got to remember, because if they actually ask you to do one on your EOC, you got to remember those steps. Here for this particular lesson, we're going to be using the Delta Math as a means of doing that calculation. So